Hello viewers, this is a continuation of question 2 where we had a textbook of mass 2 kilograms dragged across the table. We found that the force required to move the book horizontally, if it is exerted exactly horizontally, was 3.92 newtons, and we also found that if our force was exerted at 8 degrees above the horizontal, it would take less of a force to get it to move, so it was a bit easier to get it to move. We'll now look at what happens if we apply a slight downwards force. So now we've got a force which is below the horizontal, so let's say looking in the vertical direction the applied force is downwards. We also have a downwards weight and a normal force acting upwards. If that is in vertical equilibrium, which it needs to be in order for there to be no vertical acceleration, then N minus W. N is in the positive direction, which is upwards, W is downwards, therefore negative, and same with A equals 0. Therefore the normal force is the weight plus the downwards applied force. So having that applied force downwards means that there is more that the table needs to do in order to support the weight of the book plus the applied force, and therefore the normal force increases, therefore the friction force increases, and it will be harder to therefore move the book. So force due to friction increases. That's what we're expecting, and in part A we're going to verify that by way of a calculation. So let's do our proper free body diagram. So we have a weight force acting downwards, which is going to be 2 is the mass times 9.81, and that's going to be 19.62. We have an unknown normal force. We have a friction force acting backwards, and our force is now going to be 8 degrees below the horizontal. That will be A. So let's draw up our little table. So we've got a force. We've got forces, 4 of them. Each of them have a horizontal and vertical components, which may be 0. So we've got upwards, the normal force has a horizontal component of 0, and the vertical component is N because we don't know its magnitude, and it is positive because it's pointing upwards. We also have our applied force, which is going to be 8 degrees below the horizontal, so it's pointing to the right, so its horizontal component is positive, and we need to work out, we're dealing with its adjacent side, which is therefore the cosine side, given that its hypotenuse is A. It's positive, but the vertical component is going to be downwards. Its size is A, and we're dealing with the opposite side, so that's going to be sine of 8. We also have a downwards force. Horizontal component is 0, that's due to the weight. Vertical component is also downwards here, and that's 2 times 9.81, as we said, that's 19.62. We've also got a friction force pointing to the left. Friction is going to be, well, firstly it's negative because it's going to the left. Friction is mu, which is 0.2 times the normal force is N, and it has no vertical component. So the totals here need to be 0, and let's get our equations. So for the horizontal direction, we've got A times cosine of 8 minus 0.2 times the normal force is 0. And for the vertical direction, we've got N minus A times sine of 8 minus 19.62 equals 0. And we can solve that for N, the normal force. So N is going to be moving these two terms to the other side. We get A sine 8 plus 19.62. And then we'll substitute into the first equation into the FH equation. So if we do that, we get A times cosine of 8 minus 0.2 times n, which is from that first equation, but we know that n is A sine of 8 plus 19.62. That works out to be 0. Let's multiply that 0.2 into the bracket. So we've got A times cosine of 8 minus 0.2 A times sine of 8 minus, then we've got 0.2 times 19.62. That's 3.924 equals 0. So let's move that 3.924 to the other side. We get A, and then, so we're taking A as a common factor. So we get A, and then we've got cos of 8 minus 0.2 sine of 8 equals 3.924, and therefore A is going to be, we've got A times something, let's divide by that bracket to get 3.924 divided by cosine of 8 minus 0.2 times sine of 8, and if we work that out we get 4.08 newtons. So as predicted, if we have a slight downwards force acting there, that's going to make it harder to move. That's going to mean that we need to apply a bigger force to make it move. Thanks for watching. Over and out.